oh, well, Mr. Hudson just must be delayed. I'm not delayed. I am caught up. I got a bunch of papers on my no-name board, though. So people might need to claim their no-name papers. So we should have out 412. But then also, we'll take any questions that you have on 421. But that's not due till tomorrow, right? So if you have questions, something you want me to do, we can go over that. Oh, and I know I need to get more pencils. So if you don't have a pencil, please either get one from somebody or come up and ask me. I need to get more wood ones from over in the pod. Go ahead. All right, guys, everyone look at 412. 412, it has the fence problem. You already turned it in. A lot of you probably already got it back with a check on it. But we're going to talk about it because even though you got a check on it, a lot of us had mistakes, right? So I give you a check based off effort, right? I give you a check based off effort. If your effort's poo-poo, you probably got check minus, and you need to put some more effort in. But a lot of us got this wrong, and there was some slight misunderstanding that, like, maybe I need to go in and change this picture a little bit. We would not, when drawing a drawing, we would not label a side with two different numbers. Some of us thought that this meant this side was 13, this side is 10, that 3 goes right here. So check your drawing. We should have 10, 3, 4, 6, 14, and 3. Because mine's up on a giant screen. I don't know, I mean, if you use the entire space here, it is 14 wide. I did that on purpose. Because remember, I make your worksheets. These don't come from CPM. The questions come from CPM, but I make these. More and more as we get deeper into the chapters, you'll see, like, I type stuff in. You'll either be able to, like, hear it in my voice, like I don't type the same way CPM does, or it'll literally say Hudson Hint. Like, I went through and I'm trying to, like, help you guys out on your homeworks. So, guys, here's the other thing I really wanted to talk about, because I'm going to start to be a stickler. Square yards. That means yards that are square. But it doesn't mean the shape has to be square. So this shape, even though it's not a square, when we go to measure its area, we're going to measure it in square yards because, like I made a little key thing down here, a square yard means if you did a yard by a yard and made a square, it's 1 square yard. But if instead I look at pieces of our shape down here, like if I cut this right here, because this is what we call a complex shape, right? It's not like just a rectangle or just a square. So if I cut this, it's 10 by what? 10 by 3. So what's 3 times 10? 30. You with me, Kylie? Because I know you got that beautiful, what is that, a platypus? I think he's making platypuses. So this would be 30 yards squared. Guys, go ahead and write this in. Even if you already got a check on your homework, write that in. But we got to show that we split this up to make our life a tad bit easier. What are the dimensions of my section that is left over? Yeah, it's 4 by 6, which makes 24 yards squared, and we need that label. Like I put on my post-it right here, area is always something squared. Even if we're talking about circles, even if we're talking about like any other shape, doesn't matter. We always call it units squared because it's talking about how much space gets taken up, how much flat space. So now if we put these together, how many square yards do we need to replace? What's 30 plus 24? 54. So guys, a lot of us got this wrong down here where we said at $2.43 a square yard. I wanted to circle back to this question because this is a proportional relationship. What would 0 cost? 0. So when we have that 0, 0, and we have a consistent price, it's our input, right? The 54 yards squared is our input times a number. This is what we talked about yesterday. Input times a number. I would pull my notes out, but I gave them away because people were absent. They came and talked to me, and I give away my notes. If you are absent and come see me. I'll trust your math. 131 point what? So we're going to spend $131, a little over, on our grass, which isn't that bad, honestly. That doesn't seem like that much. I spent $200 just to get some electric wire. Like literally a bundle of 50 feet of wire was over $200. It was insane. Prices are crazy right now. So guys, the other thing that concerned me is on the back. So let's look at the back. And here's where we have to do another conversion. Why are we going to have to do a conversion? Yeah, Far? Right now it's in yards, but they want it in feet. And I don't know if I told you, I think a lot of us should remember this. But if you don't, and some people came and asked me, what does 1 yard equal? How many feet? Yeah, a yard is 3 feet long. This is a yard. Versus, hey, look over here. Actually, I'll step up here so people aren't cranking sideways. This is a meter, and a meter is longer by that much. Like you can see the difference between these two sticks. So when we talk about a meter is not a nice 3 feet. It's a nice 100 centimeters. But a yard is 3 feet long. A meter is slightly bigger. So we got to go back to the front, add up our perimeter. What did we get for our perimeter? Oh, that 20, 30, 40? Yeah, I think we got 40 yards. So we would say 40 yards. And guys, pretty soon we're going to be like wanting to master this. So if you didn't write it down like this, you can do it right now, even if you already turned your homework in. We've talked about conversion factors, but I'm going to keep saying it because it's something I'm supposed to teach you about. What happens if I put the label yards on top and the label yards on bottom? They cancel out, right? So that's what tells me where to put my numbers over here. I want the label of feet on top. I also know that there will be more feet than there are yards because feet are smaller. There will be more of them. So there will be more feet than we have yards. That's how we can confirm our answer should get bigger. It's 120. Make sure you label. You got to label. Otherwise, it's real confusing when people look at your work. But then if it costs 25 cents per foot, guys, some of us fell into the trap and we thought per meant division here. They already did the division. We have to do what? We need to multiply because we're saying if I'm buying 120 feet and every foot costs 25 cents, so we're going to do times 0.25. And, well, that's really like divide by 4, right? It's a fourth. So I believe it's $30 for fencing. Guys, that has to be a cheapo plastic, like temporary fence. There's no way you're getting a decent fence for that price. All right, so that's the review I really wanted to do from 412. If you want more help, this is like exactly like what we do at Math Lunch, guys. We look at the homework, we say, what's confusing? Let's do it together. Right, so if you want more help, please come to Math Lunch. For D, we would just add up the 30 with the number that we got from the front. I got a question for you guys I want you to talk about with your group. How tall do you think you could stack pennies? So, like, I have a bunch of pennies. I'm going to come around and bring a bunch to each group. But, like, most people are like, well, I was tall. Like, it all depends on how good you are. And there's actually a scientific reason that you can't stack them, like, super, super high. Well, you're going to talk about this as a group. Hold on. But so if we start stacking pennies, like, what do you think? Like, how tall do you think you could get your stack? And then how many pennies do you think that would actually be? Just take like a minute or two, chat with each other. We're going to try this in a minute, but just talk to each other. Kind of set a goal for yourself. How tall and how many pennies? Nope, talk with your group. I'll come around in a second. The new worksheet, once you have this conversation, because there's something on it I don't want to show you yet. Straight up, straight one single stack. You want to bump? Oh, there's a couple of desks in that place. If you want to bump them with people. Those right here with Vanessa and Cara over there. Not Vanessa. Antonella and Cara over there with Vanessa and Hayden. Here's the mic. Have some money. Can we turn that in? Absolutely you can. You should have turned it in when we did. Yeah, I know. Yeah, everyone's like, wait, no, our hands are trying to stack pennies. So, I know your desks are straight up. And here's the problem. Even if I ask you, stack these pennies as high as you possibly can, the world's working against you. We got somebody smarter than me here to explain why. So I gotta pause my video. Instead, I'm gonna in a minute bring you around a table that has like height of tower and number of pennies. But notice, how are we gonna measure height? What's our label there? Centimeters. So we're gonna use centimeters because they're much easier to work with. Katie, we're not trying to lift off. So start talking with your team. How can we measure pennies using centimeters? I really doubt you're gonna be able to measure a single penny. So we might have to think beyond a single penny. And I hate to tell you, but your ruler's broken as soon as you even grab it. Your ruler doesn't start at 0. So please be aware that if you put your ruler on the desk, like behind your stack of pennies or whatever, that's going to screw you up because it doesn't start at 0. So we might have to like lay the pennies down or have one person hold the pennies while the other person measures. See what you can figure out. Try to get the nicest numbers you can. Like a whole number of pennies and a whole number of centimeters. Get a nice... Measuring one's going to be real difficult. I would try to measure more than one. What number of pennies? All of these is not a number. Ooh, you stacked them all? How tall is it and how many centimeters though? 21 or 3.5? Show me. You got 21 pennies? potentially like put your water bottle lid under it or something? I don't know. Could you lift it up somehow? No, I want a piece of tape. You said you were about to ask for some tape? Okay. And I want some tape. Nope, that's all you got. That's the end of the roll. Anyone think they have nice numbers? Carmen? 3 centimeters was what? Was what? But how many pennies were in it? Yeah, I was about to say all of them is not a number. How many? Well, count them. They said they got 3 centimeters was 20. 80?
We got 2.1 and
15 pennies was 2.1. Hold, hey, let's come together. Hold on, I got some side conversation still. Vincent, what'd you guys get? 14 was 2, he says. Those are nice numbers. Yo, come with me here. We'll zoom into the world real fast. Hey, look, a stack of pennies, but I taped them because, hey, I like to work smarter, not harder. And I didn't have any partners, right? If you didn't have any partners, you'd need somebody else to hold the pennies for you. So, hold on, let me see if I can get my focus back. It may never come back. Okay. All right, so now, if we lay our ruler so we can actually count things and we zero up, I'm going to try to just say, okay, I'll put my 0 at the edge of what's on my paper. I'm going to put my 0 there. So like there. What? I don't know what you're trying to do. It was me trying to take a picture, but I don't know. Ah, it's actually just going to stay there. Sweet. If we count the pennies lining up at 1 centimeter or count the pennies lining up at 2 centimeters, it is a nice number. And then on our worksheets here, what we give you is that 4 centimeters. I have a feeling I did not count this right. There's 3 for you guys, 2 for you guys, I need 3 more for you. They tell us 4 pennies is 4 centimeters is 28 pennies. I want your team to work to finish the table over here, fill in all the missing pieces, and then make a graph of this. Make a graph of this, because look at your homework. One of the things on your homework is to make a graph just like this. That's why we're going to practice this together. So regardless of what your team found, we're now using what's on this table. The major point that matters is 4 centimeters was 28 pennies. When we go to graph this, we're going to put height on the y-axis. We need to finish our table first. So if it's 4 and 28, what would go with the 1? Yeah, 4 goes with 28. What goes with the 3? Then I'll fill in the rest of our table. Ah, we pulled out our multiplication table to look at the sevens. That's a good idea. So if 28 goes with 4, what would go with 1? So make sure we're working together. We'll go with anyone for this. How many pennies would go with 1 centimeter? 7. The 428 should tell us that it took 7 pennies for every centimeter. So there's really like a multiplication of 7 happening. Feel so smart? That too. That also works. So what multiplication? Ooh, wait, did you do that in your head? Oh, there's a calculator. You got Miss Martin right there. You don't need Mr. Hudson me. But I'm going to lean on Miss Martin. I think it's the 18th today. And what I heard her discussing with some people is there's a relationship across this table that we can see first here, and then we kind of verify here. If I'm going from the left side of the table to the right, what am I doing? Multiplying by 7, right? Good broken up answer there, guys. So here, if we do 15 times 7, Katie said we can just grab a calculator, right? Work smarter, not harder. What do we get here? I challenge you, not right now, but I challenge you to try to stack 105 pennies. I don't know that we'd be able to get that high. What's 9? But wait, John, hold on. Sorry, I got to use random cards. But John, what? I thought we were multiplying by 7. Oh, if we're going the other direction, instead of multiplying, John said we could also just divide. Ah, clever, clever. Class, what's 3 times 7? 21. 12 times 7? 84. So, now your challenge. On your x-axis, we're going to do number of pennies on your x-axis. How far up do we need to go on the x-axis? 105. This is our highest number. What's our highest number on the y-axis? 15. So let's choose a scale over here. Talk with your team. What scales would be appropriate? Guys, I'm just going to use the edge of the graph as my axes because it kind of looks nice. And we only need the top quadrant. We should be counting boxes to help us determine a scale. If you use the entire graph, it's 23 and 17. I said that at the beginning of class. Did it disappear? Gravity works. If we use the whole graph space, I counted 23 boxes wide, 17 boxes tall, if you want some confirmation. So guys, does our y-axis, bring it back for a second, our y-axis going up to 15, do we need to scale this or can we just count by ones? We can count by ones here. We don't need to like overwork to get the height. Count by ones. 1, 2. So I'm going to label 1, but then we don't have to label every single one. So guys, 1, 2, 3, 4. I'm going to just then label the 5s. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And it fits. Katie, do you got a suggestion for our x-axis that needs to go up to 105? Aw, Franco, we miss you, dude. It's okay if you need to pass, but then Franco's card was after yours. That's why I said, aw, Franco. Yeah, you're fine. I heard your group talking about it, and I think you guys were onto something back there. Marina, what about you? We'll just circle around the whole group. If you pass, it's going to Layla. Layla. Yeah, we could go by tens. Now, here's the thought. Here's the thought, though. We said in another lesson, we want to use as much of this graph as possible. If we go by tens, we're going to get up to 230. We really don't need to do that. Vincent? Oh. If we went by sevens, that's kind of working the system, right? You're kind of like, make my scale this number that we already have. You could, but I hear a couple people kind of yelling at me, go by, if we went by fives, that would be really nice to cover most of the graph. So I'm going to go ahead and just go by fives. I know my points won't be as nice. Guys, Vincent had probably the cleanest idea. If you went by sevens, all your points would look really nice. But math doesn't always work out that way, so I'm going to have us practice going by fives. So I label my first box, and then you can label whatever you want. So 10, 15, I'm probably just going to jump around. 25, 30, 35, 40. See how we almost use the entire graph? Now let's plot the points that we have. So this is weird though, and I did this on purpose. Guys, this table is like backwards. It's giving us the y and then the x. Our tables aren't always like super nice to us. So this is an x of 7 when y is 1. Be careful. That'd be like right about here. Right at 7 pennies and 1 centimeter. Be careful that you don't go up to 7. That would be the trap door, thinking that this is an XY table. It's actually a YX table. The next one is 15, 105. So we jump all the way up to 15, all the way out. 105 is nice, though. And guys, crap, that's in the wrong place. That's at 110. This is why you should do this in pencil. This is bad. Don't use that point. Guys, that's everything we have to graph. That's everything we have to graph. John, you got two of these, right? And they work, they function, they
raise up and down.
They raise. You say really good things, but you're just like jumping in, and I think it gives other people like less time to think. John. What about the line? How tall would 0 pennies be? 0. So John's saying, we know this point. We also know this point because we went ahead and put it there. But we know that this will be and I love that he said direct line, because that's actually another word for what we're talking about here, is direct variation. Guys, we know this will be straight. Is there going to be some weird situation where the tower all of a sudden gets really tall? No. This is going to go together. It's, what did we say yesterday? What's that P word? It's proportional. All of these other points are graphed now. Since we drew the line, every single other point that we could talk about, well, up to the end of where we drew the line, they're there. We just drew like 1 million points at once. Seriously. Because you could zoom way in. But in this situation, what would limit what would make sense? Can we have partial numbers of pennies? Can you like slice a penny that you can only stack half of it? You might need lasers, right? Like, I don't know that I have access to lasers. But funny story about partial pennies. When I was in college, and college kids are a lot like middle school kids, I feel like. When I was in college, we got an ad in the newspaper that said, crap, what was it? Oh, yeah. It was for Sonic. And Sonic had this new chicken slider, and this was like a decade ago, guys, so prices were cheaper. And they had this price on their ad. Now, what sign or like unit do you think they meant for this to be in? Dollars, right? Someone done goofed. This ad had a cent sign on it. My hunch was they were debating, should we put 50 cents or $0.5? And they accidentally did both. So you guys know me pretty well by this point. What do you think I did? I cut a penny in half.
How?
And my buddy has special like scissors for working on cars. They cut metal. So we cut a penny in half. Yeah, you're good. We cut a penny in half, and we went to Sonic. And they immediately got the manager. And the manager came out and said, you know this is a misprint. And I said, I know, it's a printed advertisement. He said, you know we can't sell you this. And it was a whole thing. But you can't work in partial pennies, right? That's essentially what he told me, is we cannot accept partial pennies. And actually, fun story, if you destroy currency, that's not actually like legal. Don't destroy currency. So a penny's just a penny, right? But like if you light a dollar bill on fire or whatever, like you're not supposed to do that. That's illegal. So don't destroy currency, but you can put it back together. So we then super glued our penny back together, and we went on with life. But if you like rip a dollar in half, you can tape it back together. It's still currency. The banks will still accept it. Let's talk about a couple more proportional situations. All right, so I don't know about you guys, but I love cheese, especially on my pizzas. But I love cheese. If we go to the store and we're comparing 5 pounds of mozzarella that cost $15 with 3 pounds of Havarti that costs $7.50, I want you to talk with your team. And I don't care if you write anything down for this. This is really like, let's make sure we understand these ideas. Which cheese is cheaper, but like not 15 versus 7.50? Which cheese is cheaper per pound? I was only buying 1 pound? Chat with your team. Yeah. Oh, we're going to talk about this one really quick, but these are your answers essentially. So the words that I put in there are the words you're going to use for your answers here. So like with this one, if you look at did parentheses like move to a different part of the problem? Not really. The parentheses kind of move, but what actually happened here is a property we're still learning called the distributive property. So we're going to talk about that before you get out of class. Your first answer there is the distributive property. Yeah. Are you kidding? I do. I eat like a pound of cheese every week. Yeah, but you got to eat other things, otherwise your body will get all stopped up. All right, we are almost out of time. Ugh, can't reach over my mic. Eli, how could I? Hey, bring it back together because we're almost out of time. We're doing this problem, then we're looking at your homework real quick. How could I figure out the price per pound of mozzarella, Eli? Guys, this is super confusing, so please pay attention. And of course, my highlighters didn't take, so I'm just going to re-highlight. Per is a really misleading word. Per, and guys, you can write this on your notes or on graph paper, or just really focus on what I'm saying. You don't even have to write this down. Per either means do a division or somebody already did division. So what Eli's telling me to do for our mozzarella, if we want price per pound, this tells us what to do. Because they're not giving us the price per pound, they're asking us. So we need to do a division. We do the price divided by the pounds, and we get what? 3. But guys, now when somebody tells you that, when like Eli says the answer is, he's going to say $3 per pound. And that does not mean that I need to divide. That means Eli did the division, and now I can multiply by however many pounds I'm buying, and my group over here is going to judge me for my cheese consumption. So 2 pounds, multiply by 2. 7 pounds, multiply by 7. 15 pounds, probably go to the hospital. All right, look at the homework real fast, because I want to help you out before we get out of here. 41 is exactly like we did in whatever this number was, because apparently I didn't give you a number for this up here. So 41 is exactly like that. Well, maybe, because it asks you, is it proportional? So I don't know. It may or may not be proportional. We don't see a 0 point here, so I don't know. They don't give us a 0 point. But guys, look at the back. 42 is a probability problem. So what I'm looking for is like P of, and they say each color, so we need to talk about each of them. It's like P of brown. And then there'd be a fraction, right? P of green. Because this is how we write probability, and we need to get into that habit. 43 is a lot like the Cecil tightrope problems that we've seen before. And then 44 is one where I typed a lot of extra stuff. So look at 44 real quick. We're identifying the property or operation or idea that lets us go from step to step. And one that we haven't talked a lot about yet, that I wanted to go ahead and give you, is right here. This would be distribute. Guys, if you're packing up instead of doing this, I'm doing your homework for you. I didn't have teachers that did our homework for us. Because what they're showing us is the 2, and guys, please draw these arrows so this makes sense. The 2 multiplies by 7, and the 2 multiplies by 3. But a lot of us are probably thinking, wait a minute, why didn't they add the 7 and the 3? This is another route we're allowed to take because it gets the same answer. What would 2 times 10 be? 2 times 10, 20. If I do 2 times 7, 14. But wait a minute. The negative, this is why I wanted to look at this problem with you guys, is this 2, sort of, it's negative 2. The sign goes with it. So that's why this shows negative 2 times 7, or you can say minus, and why this shows negative 2 times 3, or you can say minus. But either way, this goes with the 2. So these together then make that 20 that you would have had. All right, we're over time, so we got to get out of here real quick. Leave your pennies on the desk. I will come and get them. Just please leave them here. I need them. Do not take them. It's not much money anyways. Sweet. Yeah, math lunch. It's a thing. I didn't even bring lunch today. I don't plan on eating until later.